How's it going? This is Dr. Schulman. I know I did a pretest before. We're gonna do one more pretest just to see where we're at and how things are going before we start going through all the content. So this is through Mometrics, and Mometrics is a great program. It's a great website. It's a free website. And it's got a lot of good test information. Now, this is one more away from the exam you have to take in New Mexico. This is for 5018 instead of 5017, but it's got all the information and then some. So the plan is for you to try the exam, just questions 40 through 80. So I know that's a lot. It's a lot more than last time. And I'm going to do it myself. I'll see how many I get right, how many I get wrong. And then after you do it, you just reflect on your score, think about where you need more help, think about how the videos are going so far. I know it's just the second one, but that's what this video is. So I'm going to share my screen and I'll let you know exactly how to get to it. So if you go here to my FFCC, this was the introduction where I went through some basic information about the course. And now we're doing the second pretest. Now, if you click this link, it will give you the ability to start the exam. They're realistic, they're tough, they're nice and hard. And you can skip around, see where you want to go to. And I'm going to be doing all the work here. We're going to do 41 through 80 and see how we do. But after you finish this, I just want you to fill out a discussion post, say how you did, and just let me know exactly where you're going to study, what stuff you're most worried about. The only thing is this one doesn't really have the content. Doesn't have like the instruction. Sorry, it has the content and the instruction. It just doesn't really have the two other pieces, which are the curriculum pieces, which I'm going to start with the next video, and the assessment pieces, like everything in the middle. All right, let me move this to the top. I just like things in order. So you click on this, we're going to click start test. This is what it's going to look like. We're going to click start, and it starts with English. There's 160 questions. I know a whole ton. This costs money. Everything I'm going to give you is free though, so that you take the test for free. You may have to put an email. It's just loading. And I'm going to do all the work here from 41 to 80, and I'll be explaining lots of stuff along the way. I'm going to shorten this. I might have to reload the page. That's okay. And hopefully I won't get too many wrong. So I got one wrong the first time. We'll see how it goes with this one. I just reloaded the page. Hopefully it'll work this time. It gives you how your practice tests are doing here. Here's question number 1. It's English. Oh no, it does have the testing stuff too. But we want to start at, I think 40 is where math starts. 39 is English. Notice that there's a timer here, which is good. Notice that you can change the font size, make it nice and big. Whatever's going to help you see it. You can reset stuff, report errors. It's just a great page. So this one's still English. I think it starts at 40 or 41. And at this point, I would pause the video and I would try all of these yourself. Try all of them yourself and see how you do. And whatever ones you want to watch me do, guess what? You can see it after you've tried it yourself. So here we go. Here's 41, and I'm going to go through all of these to start with, and let's see how it goes. So here's number 41. Oops, sorry about that. Here's number 41. It says a dartboard consists of 2 concentric circles. So here's my dartboard. All right, I'm going to grab a different color. 2 concentric circles with a radii of 3 inches. And it says the other one has a radius of 6 inches. So there's a longer one of 6 inches. If a dart is thrown onto the board, what is the probability? So it's whatever we want over the total for probability. What is the probability it will land on the inner circle? The inner circle. Okay, so we want to know just this inner circle. So let's figure it out. So the total is actually out of not six. If the dart started onto the board, was a probability that the dart will land on the inner circle. So two concentric circles, 3 and 6. So the bigger one is 6 inches. So the total is 6. The top one is what we want is just here, which is 3. Now, if you want to know area of a circle, it's pi r squared, just so you know it. This I'm going with a half, because 3 divided by 6 is 1/2, 0.5 or 50%. But what if we were going to use these? All right, so we're going to do area. Let's just see if it gives us a different answer. So we have 3 squared pi, and I have 6 squared pi. Well, this is going to be 3 out of 3 pi is 9 pi's, right? 3 squared. So a square. Sorry, I should go over the formula first. So the area of a circle is pi r squared, okay? The radius of the first one is 3 squared times pi. And a square, you could just think about it as literally a square. It's 3 by 3. 2 3's get multiplied. It's not 3 times 2. It's a square. 3 times 3, which is 9. So the top is 9 pi's. That's a little circle. The other one is 6 squared, which is 6 by 6. So this is 36 boxes. That's how it works. This is, you can see it's 9 boxes, 36 boxes. Now the other one is 36, right? So the pi's, if it's ever the same, the top and the bottom just cancel. I'm left with 9 out of 36. So I got actually 1/4. Because it's a circle, I think I'm going to use the formula pi r squared. And so I'm going to go with 1/4 actually. So we'll see. We'll see if it's right. So the first one, number 41, I'm going with A. Let's see if how I did moving forward. Let's try 42. A ball has a diameter of 7 inches. Which of the following best represents the volume of the ball? Okay, so volume of all right, so area versus volume, right? Let's think about this. So area is just the base times height for like any shape, as long as it makes the right angle. That's why it's like base times height. A triangle you can cut in half, but it's basically just going to be base times height. Now for volume, it's just the height times the base area. Okay, that's the difference. So now if I have this, and it actually goes like this, it's going to be the area of the base. That's why it's length times width times height. It's going to be the area of the bottom, whatever the bottom is, times the height. However, the volume here is pi r squared, because that's the area of the base of a circle, times the height. So it's pi r squared because that's the base of it times the height. So I believe there's also a I believe there's a 4/3 here for it. I believe it's 4/3 pi r squared h. Yeah, it's actually 4/3 pi r cubed. All right, so we have this one, which is going to be 4/3. I want to leave all the answers on this line so I can check. So this one, I thought it was 4/3. So because it's a sphere, it's a little bit different. 4/3 pi r squared, pi r cubed. So it's 4/3, but 7 is the diameter, which is all the way across. But we just want the radius. So the diameter goes all the way across. The radius is half that. So it's 4/3 times pi times 3.5. Because if I cut 7 in half, I get 3.5, and I have to cube that. Cube is just like the squared, okay? So if I have a cube, I can think about a cube. It's 3.5 times 3.5 times 3.5 times 4/3 times pi. And pi is just a circle constant. Pi itself is the difference between the circumference, and circumference is the distance all the way around of a circle divided by its diameter. So if I take the whole circumference and I divide it by the diameter, no matter what circle it is, I get 3.14. That was actually discovered by Srinivasa Ramanujan, who's pretty cool. They made a movie about him if you want to watch it, but he did lots of stuff with infinity and pi. And he has a great story because he was a clerk. He was part of the untouchable class in India. So he just bagged groceries, and his friends were like, wow, your math writing is really crazy. But he couldn't pass high school because his English was so poor. But his friends, at the behest of his friends, are like, send out your journals that he's been doing his math in. They all send him back to him unopened, except for this guy Hardy in England. And Hardy saw it and thought he was brilliant, and they're still publishing stuff from him today. So the movie is The Man Who Knew Infinity, if you're interested in, but he's the one who really helped us get this idea put together. So I'm just going to use a basic calculator. 4/3 times 3.14 times 3.5 cubed. 4 divided by 3 times 3.14 times 3.5 times 3.5 times 3.5. It is 179. There it is. There's the answer. So for 42, we got B. Let's keep it going. Let's go to 43. First two were formulas. I will go over all of them. All right, so which of the following pairs of equations represents the lines of symmetry in the figure below? Okay, so lines of symmetry. Lines of symmetry just means, can we fold it and all the points match? We fold these points, will all the points match? So we have this shape for 43, right? This is, it looks like a parallelogram because those are parallel. Looks like a parallelogram to me because it has two sets of what's parallel lines. And parallel lines are just lines that are, guess what? They're never gonna meet. That's what it means. So two sets of parallel lines. And basically, it looks like if I cut it right here, this one will match here, and this will match here. And if I cut it this way, so I guess it's more of a kite. It looks like a kite. If I cut it this way, it's going to match here and here. So this is the line. Every point on this line is going to be equal to x equals -4. Now, you might get confused because that's your x-axis and that's your y-axis, right? You might get confused here. But look, the x, I go across, and the y go up and down. But then how is this x equals 4, -4? This means the point -4, 0, negative, that's the point -4, 0, -4, 1, -4, 2. So all these points, the one thing that matches on them is that their x is equal to -4. -4, 0 is right here. -4, 1 is here. -4, 2 is here. So that's what that means. The same thing for across. This is the line y, even though it's on the x-axis, this is the line y equals 6, because this is the point 0, 6. That's that point 0, 6. Oh, sorry, 0, 6 is up here. This is the point -1, 6. All -1, 6, -2, 6, -4, 6. So that's the answer. So the lines themselves are actually y equals 6 and x equals -4. So it's y equals 6 and x equals -4. So for 43, I got A. All right, let's go to 44. Remember, this was by Descartes. Descartes made this. He's pretty interesting. He made the quote, "I think, therefore I am." But he came up with these lines. They're called the Cartesian coordinates. There's your x. It always goes across like that. That's your y. And that spot right here in the middle, the 0, 0, this is your origin. It's like the start of your story. All right, let's keep going. All right, so here we made it to number 44. Okay. Which graphs do not represent the data below? Okay, so this is called a stem and leaf plot for 44. That's stem and leaf. All it means is that this is the big number, this is the tens place, this is the ones place, right? Yeah, so this is 42, 43, 48, 48, 50, 51, 51, 51. There's three 51s. There's more 50s than everything else. Then we have some in our 60s. Notice that there's like kind of like a bigger gap here. Kind of show you what all the pieces are. They want to know what's the difference between the 30s, the 40s, the 50s, the 60s, right? And we'll have to figure it out, right? So here we go. We have for our 30s, we have how many terms? 1, 2, 3, 4. We have 4 terms in the 30s. In the 40s, we have how many terms? 1, 2, 3, 4, 5. 5 terms. I'm drawing a histogram right now, which is just a bar graph. For the 50s, I've got 1, 2, 3, 4, 5, 6. I have 6 in the 50s. And then for the 60s, I have 1, 2, 3, 4, 5. There's 5 for the 60s. So I think I already know what the answer is, but 5, 10, 16, 20. So this is out of 20 as a whole. So we have 4 out of 20, 5 out of 20, 6 out of 20, and 5 out of 20. So we'll save this one. This is called the box and whisker plot. It shows how spread it is. But look, it ends at 63. It starts at 30. I'll show you all of them. Actually, why not? I'll show you them all. So let's see if this makes sense for them. Is the green 20%? Well, what's 4 divided by 20? Sorry. Top numbers in the house, small numbers on the outside. So here we go. I can't put a 20 into a 4. I can put a 20 into 40 twice, so it's 20% or 0.2. That's correct. 5 out of 20. 20 goes into 5. So that's twice 40. That's 100. So this is 25%. So this one's 25%. This is 30%. And this one's 25%. You can divide all of these to get the values, but you can see this one is correct. The bar graph is off. Oh no, this has cumulative frequency. So this is everybody preceding it. That's what cumulative frequency is. So cumulative means when we are adding them all up. You might think it's wrong because it should be curved like this. This is relative frequency. But when they say cumulative, means to add them all up. So this means the first one is the 30s. We have 4. The 40s, we have 5. This is, okay, let me make it better. So 40s are 5. So we'll do frequency, relative, cumulative. All right, so the frequency is just how many we have of it. The 50s, we have 6, and the 60s, we have 5. So relative, we just divide it. 4 out of 20, 5 out of 20, 6 out of 20, 5 out of 20. That's how we got these percentages for this one. 20, 25, 25, and 30, which is fine. But cumulative, we add them all up. So the first one is 4. And 4 plus 5 is 9. That is 9. The next one is 9 plus 6. So the next one should be 11. It is 50 through 59 should be 11. They gave us 14. That seems off. And the last one is, oh, did I miss something? Oh yeah, because I can add. 9 plus 6 is not 11. 9 plus 6 is 15. And that is 15. Cool. And then we have 15 plus 5, which is 20. They all match up. Beautiful. So we know this one is correct because 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 5 is 20. This one's right. But what about this one, right? What about this guy, right? So I got to make this box look square plot. It shouldn't be too hard. I just need a minimum, a maximum, a median, my first quartile, and my third quartile. What does that mean? Basically, it means that I have to separate this in 4 quarters to see the spread of the data. That's all I have to do. So I have to separate this in 4 quarters to see the spread of the data. So I'm going to write them all out. 36, 37, 39, 39, 42, 43, 48, 48, 49, 50, 51, 51, 51. Keep going. I got my 351s. 55, 57, 60, 60, 61, 62, 63. All right, so I'll show you how to make this box plot. So these are all the numbers. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sweet. So minimum just means the smallest number. That's 36. Max is the biggest number. That's 63. Now we need the median. So the median, there's a formula to get it, but this just means the middle number. You can think about the prime meridian, like when they were looking for ships, they always use the middlemost route. So that's n plus 1 divided by 2. 20 plus 1 divided by 2. What is 21 divided by 2? This means our middle number is going to be between the 10th and the 11th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this is the min, this is the max, and this is the median, which is 50.5. Halfway in between 50 and 51. Now the first quartile is just everything to the left. What's halfway? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we can just do 10 plus 1 divided by 2. What's halfway there? 5. It's between 5 and 6. 1, 2, 3, 4, 5. So it's 42.5 is your first quartile. And 1, 2, 3, 4, 5. And between 57 and 60 should be, well, if you don't know how to find it, this is what I'm doing in my head. I'm doing 60 plus 57, then I cut in half. So that's 7, 117. And what's 2 divided by 117? Well, that's a 5. And that's 17. So this is going to be 8, 16, 58.5. That's what I was doing in my head, halfway between them. So that's your Q3. Now, normally you could think, oh, I just draw a box around this thing, right? However, it doesn't show you the spread. They're all equally spaced out. We want to see how spread out the numbers are. So all we need to do is make a scale from 36 to 63. I'll go by 10. So 0, 10, 20, 30, 40, 50, 60, 70. All right, so our first dot's at 36. Our next line is at 42.5. Our next one's at 50.5. Our next one's at 58.5. And finally, we're at 63. So this is the way that the box should look when we're done. So let's look at the box. 36, yep. 42.5, yep. 50.5. Oh, sorry about that. 50.5, yep. And then we have 58.5 and 60. They all look fine to me. 61, 62. So, yep, cool. So it's got they're all correct. Every one of these is correct. All right. That one was D, pretty sure. All right, let's try 45. We got our buddy Zeke. Let's see what Zeke's doing for 45. Zeke drove from his house to furniture in Atlanta and then back home. So Zeke drove from his house to Atlanta and then back home on the same route. It took Zeke 3 hours to drive to the store by driving an average of 20 miles. It took Zeke 3 hours to drive to the store by driving an average of 20 miles per hour faster. On his return trip, he was able to save an hour of driving time. What's Zeke's average driving time for the round trip? So to do this, it's basically the miles divided by the hours gives you your miles per hours or your average, right? So let's see what we know. These are our possible answer choices. We can work backwards, but let's see what we have. So the first one, we know it took him 3 hours. And by driving an average of 20 miles per hour faster. So the miles is the same. So this is miles, but we have to double it. So the first is going to be miles over here. And the second one, we are figuring out that it's an average of 20 miles per hour faster on his return trip. And we just need the average speed of his round trip. Drove from his house to a furniture store and then back home on the same route. So these are both equal. So the MPH is actually going to be equal. The hours should be equal on both. So, I mean, the miles should be equal on both. Sorry about that. So we know that we have the mileage, which is going to be the same. We have 2 miles per hour. So we have, if we can figure out the miles, we can figure out the hours. So the first one, we know it's whatever this constant is. Why is that? Because the distance is the same. Sorry. Our distance is the same. So the M is going to match for both. This one's going to be 2 hours to give us our MPH. So this divided by 2 gives us our MPH. Now this one, our MPH, we still have the same mileage. That's still M, but now it's going to be 2, but this is going to be plus 20, right? By driving an average of 20 miles per hour faster. So right now you might be confused. We have 2 unknowns, right? We've got miles here, and this is the answer we want to get, which is totally fine. We have some value. This matches, so this is just a constant, so it's going to be the same for both. So, but can we turn this into something for over here so we can work it out? So we have our miles, matches for miles. We have MPH plus 2. So if I basically make this one into a fraction, M equals 2 times miles per hour. All right, so I have 2 times miles per hour plus 20. There's another way to do it. However, I think the equations, I feel like the way I'm drawing it here might be confusing for you. So why don't we just use the choices? Won't that be nice? So we have the choices, which is totally cool. When we have our choices, we should be fine. So all we know is that by driving an average of 20 miles per hour faster, we should be able to get these two values. So the average speed on his round trip was 24. And then this is going to be, the average is 24. I'm trying to think about using the choices. We have 48. We have 50. And we have 60. Okay, cool. So you could always use your answer choices if you want to. This is another way to like do these problems. You can let your answer choices be your friends. And I haven't seen any of these before, but usually they're just like regular math questions. And we know it took Zeke 3 hours to drive to the store, right? So the way there, the shorter way is 3 hours. So took him 3 hours to drive to the store. So we know that the first one, miles over hours, equals MPH. And if I have 3 hours here, and I have miles, and then I have, this is going to be, I don't know, I'm going to skip 45. I'm going to skip it. We'll get back to it. I had a moment. All right, let's go to 46. I'll save that one for last because my brain didn't want to make it happen. So 46. For which of these rotations of 120 degrees around the center of a polygon makes it map onto itself? So basically, we have to turn something 120 degrees to see if it looks the same. We got a square. However, if I turn the square 90 degrees, it will be the same square. So it can't be the 120. So the circle is 90, 180, 270, 360. That's how that one matches. The way to figure it out is you could just take the number, we can cut into triangles. And we can see how much it turns. So now we have a hexagon. One, two, three, four, five, six. Oh yeah, sorry, I drew the wrong shape. So there's my hexagon. And hexagon, so we basically have to see how many triangles can I cut this into. 1, 2, 3, 4. So that's 4 triangles. 4 times 180, because if a square is 90 on all the corners, it's 360. And basically, if I divide this by how many sides we have, I get 90 degrees. So that's how I know how many degrees it goes. This is, a hexagon is basically the square, but I have 2 more triangles to it, right? See, there's the hexagon, 180, 180, 180, 180. So that's 360, that's 720 degrees. Now, if I divide this by its 1, 2, 3, 4, 5, 6 sides, 6 goes into 720, 120 degrees. That means every 120 degrees, it's going to look the same. So I'm going with B for this one. I'll do the same thing with the octagon. I'm just adding some more triangles to it. So there's my 8. We know it should look like a stop sign, but cutting into that triangles is hard, right? One, two, three, four, 5, 6. Yep, 6, right? There's 6 triangles. So 6 times 180, because that's how many triangles it makes, is 0. 6 times 1 is 6, so that's 1080. And what's 1080 divided by 8? Because there's 8 corners on this to spin it. I think it's 135. So that's 1, 3, yeah, 135 degrees. So that's why it can't be hexagon and decagon. So the decagon is going to be 2 more, so that's 8 triangles. So it's 8 times 180. Just so I don't have to do the last one, 8 times 180 is 1440 divided by 10. So it should be 144 degrees. Yeah. So the next one's 144 degrees for the decagon. So 46. I'm going with B. We'll see. I'll go back to the one I missed. I just had a moment. All right, so 47. Marlon pays $45 for a jacket that has been marked down 25%. What was the original cost of the jacket? All right, so we pay $45, but it had been marked down 25% of the original term. So we could go a number of ways. We can take the answers and work backwards. If you want, we could do 80 times 0.25, 75 times 0.25, 65 times 0.25, and 60 times 0.25. If you're going to do this process of elimination, always start in the middle, because then you know if you have to go up or down. So you have to do them all. So that's obviously a way you can do this problem. Just remember, you'd work this out by pretending like these aren't there. So let's just try 75. 75, let's say it was originally 75 bucks. 5 times 5 is 25. That's 375. Hold the place. That's 10. 2 times 7 is 14 plus 1 is 15. So I have 5, 7, 8, 1. So $75 minus $19. I'm just rounding here. We have too much money. We have 46. So I know it can't be 80, right? 80 is too big. I know it can't be 75. It's too big, but it's barely bigger. So I'm going to go with 65. Let's see how 65 works out. 5 carry the 2. 32. 0. 0. And now I have $16.25. And I'm still I have change here. So it's gotta be 60. I'll show you the right way to do it after. 0. See how now I don't have any change? Now I have 16 bucks. Wait, did I make a mistake? You know what? We all make errors. $15, not $60. $16. All right, so 0, 30, right? That's the first one. Now it's blank, 0, and 2 times 6 is 12. I don't know how I got 13. I don't know how I got 13. There's your $15, and 60 minus $15 is $45. And that's what we wanted. So what's the right way we should have done 47, which is D? Oops. What's the right way we should have done that? I'll show you the right way. But you can go do this any way you want. I was trying to show you before that working backwards could be really helpful for students. But let's see how we're supposed to do it. So we know that Marlon pays $45 for a jacket that has been marked down 25%. So how can we do this? Basically, it's going to be what we don't know, which is X. And then we have to subtract 0.25 times X. This should give us the right answer. This should give us the right answer. So it's the total jacket minus 25% of that jacket. What is X? We should always have a little label here. So let X equal the cost of the jacket. So what we paid, the total cost of jacket, the original cost of the jacket, minus 0.25, 25% of the jacket. So 45 equals, well, when there's not a number in the front, you can think of it as just a 1. So what's 1x minus 0.25x? That's 0.75x. Divide by 0.75, divide by 0.75. So this is our problem. It's 45 divided by 0.75. Top number special lives in the house. There's your bottom number, 0.75. Now, notice, I can move this once, twice. So if I move that 2 places, I got to move this decimal 2 places. So it's really 75 into 45,000. 75 can't go into 4. 75 can't go into 45, but 75 can go into 450. It should go in, I don't know, what is it, 6 times? I don't know, let's try 6. 75 times 6, 6 times 5 is 30, carry the 3. 6 times 7 is 42, 45. Nice. 450. And how many times is 75 1 0? $0. 60. So this is the other way to do it. Whatever makes more sense to you. But guess what? We got the right answer either way. $60. So for 47, I got D. Let's go to 40, 48. We're on our way. Aiden has a plastic container in the shape of a square pyramid. So the first thing I'm going to do for 48 is to draw a square pyramid. So this is a square shape on the bottom. That pyramid means there's all triangles that kind of meet at the top. This is what a square pyramid looks like. Okay. He wants to fill the container with chocolate candies. If the base has a side length of 6, but this is square, so they're both 6. And the height of this thing is 9. How many inches of candies can go on? Well, the base is 36. The height is 9, and I think it's times 1/3. I think it's times 1 because 3 of these fit in. Yeah, it's 1/3. I just like to make sure 1/3 base times height. Perfect, because 3 of these go into the box. Nothing too crazy. So it's 1/3 the base area, which is 36, times the height. Well, 1/3 goes into 36. You can do top times top times top across. But I'm just simplifying. 36 divided by 3 is 12. So our answer is just 12 times 9. 9 times 12 is 18. It's 108. 48 should be C. 108. All right, let's try 49. All right, we got Mr. Sarver, a second grade teacher, noticed that we do have it. Okay, so we do have the teaching ones here. So this one does have it all. A second grade teacher notices that a few students are struggling with the concept of borrowing when subtracting 2-digit numbers. Which of the following activities would help his students better understand this concept of borrowing? The teacher works subtraction problems on the whiteboard. I like it. The students watch the children. I don't like B. B sounds like doesn't make sense. The students complete a worksheet with subtraction problems. Okay, so A and C both look the same. A and C look the same. I would do the manipulatives. Cardboard manipulatives, where they actually subtract. I think this one makes the most sense. I'm going with D. Because I think that the whiteboard and the worksheet are the same, and the video, I think they're all kind of the same. So let's have them do something. All right, let's go to 50. Oops. So I went 49, I went with D. Let's go to 50. All right, Coach Waybright, sixth grade basketball team has played 36 games this season. The ratio of wins is 2-1. If X represents the number of wins, which of the following proportion can be used to determine the number of wins? All right, so I'll show you what this means. So this is for 50. We know it's 2-1 is wins to losses. All right. But they told us that he played 30. So this is wins and that's losses. And it says that he played 36 games. So that's a total. I don't have a total. We want the number of wins. So we want wins over the total. And then I can figure out how many wins we have out of the 36. So that's what we're going to do. So we have 2 wins for every how many games? Every 2 plus 1 is 3. This is how odds work. It's usually wins, losses, not wins out of the total. And then it's how many wins we actually have out of the 36 games. So there's a bunch of ways. I'll show you 3 ways to do this problem. So we can do this way. The first one is, sorry. So we could do 3 times 12 is 36. So 2 times 12 is, they got 24 wins. That's one way to do it. The other way, X is divided by 36, so you can multiply it. The opposite is, so it's 36 times 2 is 72. Divided by 3, it's top times top, bottom times bottom. And we're getting 24 equals X. And the final way you can do this thing, and this is the way I like the best, whenever you have a 2 fraction equal sign, I always tell my students to think of the equal sign as a thorax, and I draw antenna, and I draw wings, and I say butterfly to cross multiply. So X times 3 is 3X, and 2 times 36 is 72. Divide by 3, X equals 24. But they just wanted the problem. So 2 over 3 equals X over 36. So 50, I got what? I got D. All right, we're on our way. Let's go to 51. Okay, so Mr. Orr asked his class to use inductive reasoning. So inductive means we use little rules to get it. And that's the difference between inductive and deductive reasoning. So deductive, you can think of like a Sherlock Holmes, like an investigator looking for clues to find it. So inductive, we take the little pieces, all the little pieces, then we create a conclusion. Deductive, we have the big idea, and then we break it down to figure out the little pieces of evidence. So use a general idea to get a specific conclusions, and these use specific conclusions to create a general idea. That's the difference. So we just have to find the pattern for 51. All right, here's 51. 2, 5, 10, 17. So to get from one to the other, I am adding 3. I'm adding 5. I am adding 7. So the second step of the pattern is we're just adding 2 every time. And that's the easiest way to see it. So 3 and then plus 2 more gives us 5. Then plus 2 more gives us 7. So the next one in the pattern is going to be plus 2 more, which gives us a plus 9. So our final answer is going to be 26. That should be a choice. There it is. So 51 is D. All right. We are back in geometry world for 52. So 52 gives us, these are called parallel lines, and this one in the middle means it's cut by a transversal. So this is called the transversal, and these are parallel lines. So we have B, C, E, F, A, D, G, H. Now, you can visualize these 4 getting ripped up and placing them on top of these. So these are all a match. Now, what else is a match is that we have anything that crisscrosses is a match, and if they're together, they're supplementary. So let's say, for example, I don't know, let's say that this is 80 degrees. Sorry, it's an obtuse angle, so it can't be 80 degrees. So let's say it's 100 degrees. So if it makes a straight line, this one has to be 80. And then these crisscross, so that's 80. And this one crisscrosses 100. That's how they all match. And if I add them all up, I get 360, which is a circle. So this is 80, 80, 100, 100. And that's how they work. These are called alternate interior angles. They match. Alternate interior angles. Your alternate exterior angles match. So these are interiors. And these are exteriors. Let's see what we have. Does E match to B? Nope, they make a straight line. Does D match to H? Nope, they make a straight line. Does G match to C? If I take G and I drop it up, it's E, and E matches to C. So G and C are a match. It's C. And D and F, nope, they're on the same side, so they make a straight line. So 52's got to be C. Let's go to 53. So we have another pattern. We have to figure out the next in the sequence. It keeps going up, so it can't be A right away. So let's do the pattern for 53. Sorry, I keep reloading the page. So we have 16, 24, 34, 46, and 60. So here we go for 53. I have 16, 24, 34, 46, and 60. All right, so let's think about this. This is plus 8. This is plus 10. This is plus 12. And this is plus 14. And it looks like the same thing we had before, but now we're adding 2, and there we're even. So nothing too crazy about this. So if I add another 2 to this pattern, I have 16. And so this one has to be 76. That better be a choice. It is. So 53 is D. All right, let's try 54. So far, there's only one I skipped. Okay. Let's look at 54. These are nice and tough. The set A, B, C, and D forms a group under the operations. Which of the statements are true about the group? A and A makes C. A and C make B. A and B make D. A and D make A. Crazy. So they give us some words. The inverse of C is C. So that means the opposite of C is also C. So what does that mean? So this means for C, A to A, B to B. E to D doesn't make it. I don't think the inverse of C is C. Oh, so this is if I have A and B. Okay, so A times C is B. Is A times B C? A times C is A and A times. I don't like that one. The operation is commutative. So commutative basically means, I'll do one of these at a time. So commutative means A to B is the equal to B to A. It means like if you go one way, you can go kind of backwards and it goes the same route. It basically means if A equals B, then B equals A. If A equals C, then does C if A times A is C, then A times A is C. If C, B makes A, then does B, C make A? Yes, it does. Okay, so BC is A and C, B is A. Is DA is A, then AD is A. Yeah, so it is commutative. So 3 is correct. I like that. What do I mean by that? So I tested it by doing B and A equal B and A equals D. So does A and B equal D? And A and B also equals D. So 3 is right. So we know it can't be 1. And if it can't be 1, then we know that these two are off because it can't have 1 and not be 1. So the answer is B. But why does 1 and 2 not work? Well, what does 1 not work? I don't know. I'm just gonna go with 3 right now for 54. So I'm going with B for 54. And if I'm wrong, I'll put a little star by it. So I knew it'll take some time for me to get to another one that I had questions about. Let's go to 55. So as of right now, there's 2 of them that I'm not sure about. But guess what? It's okay. Just some problems. In how many distinguishable ways can a family of 5 be seated in a circular table with 5 chairs if Tasha and Mac must be separated by 1 chair at least? Oof. This one already sounds crazy. So here we go. Let's look at 55. So we have a family of 5 seated at a circular table. So 1, 2, 3, 4, 5. So I have 5 spaces, right? Now, if order matters, which is important, we have so this is like the difference between permutation combination. I don't think you're going to get one of these on your test, but that's okay. In how many different ways can a family of 5 be seated at a circular table with 5 chairs? They must be separated by at least 1 chair. So we need all the ways. So right now it's 5 by 5. So it's 5p5 because order matters. I'm going to have to subtract whatever's left over. So 1, 2, 3, 4, 5. So it's basically 5 times 4 times 3 times 2 times 1. So I start with 120 ways we can move them around. Here's the crazy formula. It's n factorial over k factorial, n minus k factorial. N is the total number, which is 5. And k is the number of people or number of things we can move around. Sorry, this is the total number of people, and these are the number of spaces or groups. So we start with 120, but Tasha and Mac, so we can subtract. If Tasha and Mac must be kept separated by at least 1 chair. This one looks a little crazy. I think I'm gonna do 5p2. No, I think it's got to be 5p3. That's 5 times 4 times 3. 20 times 3 is 60. Why? Because I think that I'm accounting for the 5 people, 3 have to be separate. I'm going with 60 ways. I could be wrong. So we'll see what that one is. The 55 I'm not sure about, but I went with 60. I don't really feel like writing them all out. All right, let's try 56. All right, so which of the following steps were applied to ABC? All right, well, if I could turn this, we could reflect across the x-axis, so then it's pretty much here, but upside down. And then we rotate this thing 90 degrees around the origin. That sounds pretty good. If I'm here and I go 180, I'm over here. So it's not B. If I'm here and I go 270, I'm back where I started. And if I go here, yeah, it's A. So y is 56A. So if I have this box and I'm reflecting it this way, to go over here, it's just a 90-degree turn because each one of these is a quarter. 180, I'd be over here. 270, I'd be back where I started. And then if I go across the y, right, I'd be over here. Then it's still 90. It's not another 180. So that's why it's 56 is A. I think I said it was D for that one. All right, let's go to 57. All right, Ms. Wise asked her students to, in pairs, construct the diagrams which classify rational, irrational, real, and integers. As she walks around the room to observe their progress, which of the following criterion should she use to understand this understanding? The integer should include all 3 sets. Set of rational numbers should include the other 3 sets. Irrational numbers. Okay, so these are the types of numbers. This is like one of the first things we're going to go over, different types of numbers. I might as well tell you what they all are now. So 57. And what is a Venn diagram? Venn diagrams look like this for the most part, where it's like they could match, they could be alone, they have different properties. And I'll draw a bunch of these when we do probability, but this is what a Venn diagram looks like. All right, so we have an integer, we have rational, we have real, and we have irrational. Okay, so the integers are just basically whole numbers that can be a positive and negative. So -3, -2, -1, 0, 1, 2, 3. These are integers. Rationals can be like A over B, or so this could be like -3.26, -2.12, -1, 0, 1.23. See how they stop? Irrational is like 1/3. 2/3, pi. I don't know, like basically it just keeps going on forever. They don't stop. So irrational, don't stop. So if I put it in the calculator, it'd be 0.3333. Pi is irrational, it's 3.1415. 5. It keeps going. It doesn't stop. So that's irrational. Sorry, I think 1/3 is rational. Basically, it just can't be 2/3 is right. It's because rational could be like 1/3 because it just can't be like constantly changing as it goes through it. It's like a 2.718 dot 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 dot. That's your this is Euler's number. Now real is just everything that doesn't have an imaginary number. So this one, and this one are all part of real. So the set of real numbers should include the rest of them. And let's just look up irrational just for fun. I want to make sure I gave you a good definition. Yeah, so it can't repeat like square root of 2. So I was right. So 1/3 and 2/3 are also rational because they repeat. So 57 is, in fact, D. All right, let's see what else we got. I got 58, 59, 60. All right, let's go to 58. During unit on geometry, Mrs. Naifeng instructs her students to sketch 2 congruent polygons. Which following sketches complete the task? Okay, so congruent, right? Yeah, so for 58, congruent means equal. This is another geometry. It means equal in size and shape. That's what it means. Equal in size and shape. So that means it doesn't just have to, and this is the symbol. This means equal in size. And like the mustache over the top means shape, or you can think about similar. So they have to be the same size and the same shape. So 2 rectangles with the same perimeter don't have to be congruent because I could be like this and I could be like this. They have the same perimeter, the same distance all the way around. That's what perimeter means, but they're not the same shape. 2 polygons with the same shape. Well, you can be the same shape, but you can be different sizes. So it's not B. 2 polygons with the same side lengths. Okay, so here's a polygon with the same side lengths. Yeah, but you can draw it differently. I don't like it. 2 squares with the same area. Yeah, it's D. No matter how I draw 2 squares with the same area, they're always going to be the same size and shape. So 58 is D. All right, let's keep going. 59. All right, what is the area? So for area, you just have to count how many boxes there are. You can do a formula here, but it's just easy to count. So let's just count. That's 1, 2, 3, 4, 5, 6. So I have 6 here right away. I can see that this one and this one, if I put this piece here, it matches. So ready? 1, 2, 3, 4, 5, 6, 7, 8. Same. Okay, so it's just hard for me to see it without being able to draw right on it. So I'm going to draw it. So I'm at 59. So here's 59. I'm just going to see how many boxes I have. So 1, 2, 3, 4, 5, 6. So these are the 6 that I have the whole box. Now I have 1 here and 1 here. So my 2 sides. So that's from that was really ugly. Then I have these 2 right here, right? I got this business, which is 7, and I have this business, which is 8. And I have this piece. So this one matches to this one. So this is 9. That's 10. All right, so basically I'm dealing with this piece, this piece, this piece, and this piece. This one and this one make a whole. This one and this one make a whole. So they're all just parts of a whole. See how like this has a little bit and this is missing that little bit? So basically I just have to count the doubles as one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11. I'll double count though. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I actually got 12. I got 12. I'm going to recount it a fifth time because it's so weird to see. So here's 4, 5, 6. So these are all the whole ones, which are 6, 7, 8, 9, 10, 11, 12. Yep, it's 12. So it's C. So 60, 59 was C. All right, let's try 60. Kayla has a budget of $75 and she wants to purchase gifts for her colleagues. She wants to buy coffee mugs and notepads. She may purchase a maximum of 30 items. Each coffee mug costs $6. Each notepad costs $3. Which of the following graphs correctly shows the possible combinations of the coffee she could buy? All right. So I might as well just draw it for you guys and I'll show you. So here we go. For 60. So she wants to buy coffee mugs and notepads. She may purchase a maximum of 30 items. So to do this, we could do X is the mugs, Y is the notepads. So we could do some sort of mugs. So we can do X plus Y equals 30. But we could, she may purchase a maximum of 30 items. So it's not X plus Y equals 30. It's X plus Y has to be what? Less than 30. And whenever it's less than, it means it's a dotted line. We're going to be under this. So I'm going to do the first one. And then, which is what? We have $75. So it can be less than or equal to 75. So this is going to be a solid line, and we still have to be under it. And mugs cost $6, and notepads cost $3. All right, so I'll show you exactly how to do this one. So we just need a graph with two equations. The first one's going to be x plus y is less than 30. We want to write them in terms y equals mx plus b. There's the algebra. So y, and we don't have that, right? So we have to get the x over here. So my first step, I have x plus y equals 30. Sorry, x plus y is less than 30. And there's my x and there's my y. So I have to subtract x from both sides. So the first equation is y is less than negative x plus 30. So I'll draw a line here. We're going to make it green. So here's the line. We're going to start all the way up at 30. 5, 10, 15, 20, 25, 30. And we're going down 1 over 1. So we're starting at 30, and I need a dashed line. Because that's got to be 30 as well. And I got to color this in. Here's the first one. That's our first graph. Cool. Actually, I think I have a highlighter. So we're going to go highlight. That's the first part. Under the line and it's dotted. All right, let's do the next one. I'll do the next one in red. So here's your other equation. 6x plus 3y is less than or equal to 75. I got to get the over, so I have to subtract 6x from both sides. So that's 3y is less than or equal to negative. And the only time this flips is if we multiply or divide by a negative. Now I have to divide this by 3 and divide this whole thing by 3. When I'm dividing this whole thing by 3, this means this has to be divided by 3. I call this the lotus flower, and this has to be divided by 3. See, it kind of looks like a lotus flower. These cancel. 3 divided by 3 is just 1. So y is less than or equal to negative 6 divided by 3. That's negative 2x. And this is going to be plus 25. So my other part of the chart, I guess I'll use blue. 25. But it's going to be steeper. Now it's down 2 over 1. So it's going to be twice as what? Steep. And I highlight this in blue. That's over here. And we just want the place where it double matches. So the only place double matches the blue, that's right here. And we can pick any point. This means we pick any point in this pink, this answer. We pick any point in this answer, and we could afford it. We can afford anything in here. So let's look at our choices. Let's see which one's the right choice. Let's see what Kayla was able to do. This doesn't 30, 25, perfect. But which possible graphical key shows the possible combination? Oh, here it is. Blue, red, purple. It's A. Blue, red, purple. Oh no, but we want it on the inside. This is everything is above it. This is off. I just was looking at the lines. The lines look good, but this one should have been dotted. So we can't afford this. We can't afford this. So it's not A. We can't afford this. This is what we afford. It's just this one. So it's C. What's the other choice? Yeah. So it's C. It looks just like my ugly picture. Next. So 60 was C. And I'll go back to the ones I missed at the end. So far, I think I missed 3. Let's go to 61. What is the constant of proportionality represented by the table below? So what is happening every time? 2 times what is 8? 5 times what is 20? 7 times what is negative 28? 10 times what is negative 40? So there's only one number we can basically multiply. The constant of proportionality for 61. When they say this means y equals k times x. There's only should be one value it can be. So y equals, this is what we're looking for. So we have an x and y. Let's just use the first one. Negative at 8 equals 2 times k. Divide both sides by 2. K is negative 4. And it doesn't matter which one you choose, they'll all be negative 4. So that's why it is D for 61. All right. All right, let's try 62. All right, here's another teaching one. Let's see what we should do for 62. All right, so Miss Alejo is teaching a unit of fractions. Some students are completing an activity in identifying the parts of a fraction, so numerators, denominators. Another group of students is completing an activity on adding and subtracting. Which of the following methods instructions? Okay, so some students are doing like an easier task, just naming the parts, and another student is moved down a little bit further. So this is not small group. This would be her speak. So collaborative learning is kind of when everybody's working together on the same goal. That's not what's going on. A small group is when everybody's broken into groups, but they're doing the same thing. Non-linguistics is when we're using manipulatives and not actually using words to do it, but this is differentiated instruction. Everybody's at a different level. So 62 is D. Okay. So during an activity, Mrs. Schwartz instructs her students to place coins in 3 groups, where each group gets progressively lower in total value. Which of the following groups correctly? All right, so we just have to figure out who did this right by figuring out the money. So we're up to 63. The other one didn't really need much explanation. So Henry was with group 1. So we want to get progressively what? Progressively lower in total value. So the first group 1 is 2 dimes. So we have group 1, group 2, group 3. So group 1, we have 2 dimes. So 2 times 0.1, that's a dime. 2 times 0.05, and 4 pennies. 4 times 0.01. Group 2 is 1 dime, 3 nickels, 2 pennies. And group 3 is 2 dimes, 1 nickel, and 4 pennies. So that's 20 cents plus 10 cents plus 4 cents. So that's 20, 30, 34. This is 10, 15, 20, 25, plus 2 is 27. And this is 20, 25, 28. So we want to go lower in value. So 34, 27, 28 is not right. Graham did the 1 dime. Oh, they're all different amounts. Oh. So this one's annoying because you got to do each one separately. So I'm just going to do them together. So we know it's not A. So that's 10. So we have 1. I'm just going to do times 5 instead of working with the penny. So it's 1. Sorry, it's 10 plus 5 nickels is 25 plus 5. So we started with 40 for Graham. Then group 2 is 20 plus 10, sorry, plus 8, which is 38. Nice, Graham. And the last one is 10 plus 10 plus 9. Sweet. So this one in descending order, we're already done. So it's grams. Let's double check the other two. So this one's 30 plus 20 plus 9. 30 plus 20 plus 9. This is 59. 20 plus 20 plus 3. Well, it's going down. Let's hope the last one doesn't mess it up. And then it's 10 plus 45 plus 2. Yeah, this is off. That's 57. So this doesn't go in order. And this one is 22, 3, and this 20. So this is 20, 39, and this is 20, 21. Wait, is the last one? Just double checking these. So this is 20, plus 10 plus 9, 39. Let's see what you got, Elizabeth. And then it's 20 plus 20 plus 1. Yeah, this one's off because it's 41. So this one, 63 is obviously B. Oh, let's do the next one. Okay, cool. What is the length of the hypotenuse shown? There's a bunch of ways to do this one. This is what's called a special right triangle. It'll be like when we're looking at all the geometry stuff. But I can show you a bunch of ways to do 64, 8, 8. And this is 90 degrees, and that's 45. Sorry, this is 90. That's 45. Cool. That's 8. That's 8. This is 90. These are both 45. So you can think about this as a squared plus b squared equals c squared. So this is 8 squared plus 8 squared equals c squared. 64 plus 64 equals c squared. So that's 128 equals c squared. And then to get rid of a square, you get rid of a square. So it doesn't matter what it is. Like we used this one before, the 3 by 3 square. So if I have a square of area 9, 3 by 3 is 9, right? Now, if I want to get rid of that, all I have to do is take what's called the square root or side of square. What is one side of a square of area 9? Well, it's 1, 2, 3. So that's why it's 3. So we just need the square root of 128. 128 is 64 times 2. The square root of 64 is 8, so it's 8 root 2 equals c. I could show you other ways to do it, but use Pythagoras. He's a great guy to think about. He was afraid of beans. He was super scary. He has like a great story. I'd look him up if you'd like, but especially when you're teaching about stuff, because Pythagoras honestly didn't even have variables at his time. It was so back in the day. He just knew that the third side had to be the square of the sum of the squares of the other two sides. Very smart. So 64 is D. Let's go to 65. A cube inscribed in a sphere has a volume of 64 cubic inches. What is the volume of the sphere in cubic units? All right. This one's super hard. You're not going to probably get one that's challenging, but they've got a cube, like literally inscribed. Means like it's inside of the sphere. So we have to figure out this. So if they're saying the volume is 64 of the cube, how much is one side? We just need to know one side of this thing. And that's going to help us. One side of this thing is really going to help us. So if I have just like we have the square root, the cube root means the same thing. So we'll go back to our square of 9. Because this is 3 by 3. But if we want the cube of this, the volume is 27 boxes. So that's why the cube root of 27 means what times itself 3 times gives us 27. So that value has to be a 3. Because 3 times 3 times 3 is 27. Same thing here. What number, if I want the cube root of 64, what number times itself 3 times has to be 64? Is it 1 times 1 times 1? Is it 2 times 2 times 2? 3 times 3 times 3? 4 times 4 times 4 is 64. So that's what the answer is. So we know we have a 4 here. So we know each one of these is going to be 4. Now, what's the formula for volume of a sphere? I believe it's 4/3 pi r cubed. Four-thirds pi r cubed is the right answer. So we know a side of this thing is 4, right? Because it's 4, 4, 4. Now, the way that this gets harder is we don't need a side, we need like a diagonal, right? We need a diagonal of the cube to get the radius. So to get the diagonal of the cube, just want to see a picture. So the diagonal, if we know the side length is A, the diagonal to go from one corner to another is, ready? A squared plus B squared equals C squared, right? So they're just doing the Pythagorean theorem again right here. And they know the body diagonal of this cube is square root of 3 times A. However, we don't need the whole diagonal. We just need half of it. So it's going to be square root of 3 over 2, and that's the radius. That's what I think it is. That's going to be cubed. So it's square root of 3 over 2 cubed, but the whole thing has to be times our value, which is 4. Why is it 4? Because our A is 4 in this case. So we know this thing, if there's a circle, a sphere around it, it's got to be half of that. So I believe it's 4 times 4 times 4. I believe it's 4 times the square root of 3 is the whole thing. And then once we're done with the entire thing, then we divide it by 2. All right, so 4 cubed is, well, we just did it, was 64. 3 times square root of 3 cubed so I need the square root of 3, the square root of 3 to the third power. All right. Is there a square root of 3 in the answer? There is a square. Okay, cool. So I didn't know if I had to deal with the square root of 3. I probably don't. So I think it's going to go away. I'm going to worry about that square root of 3 until the very end. So it's 4 times the square root of 3, which is 64 divided by 2. So this is going to be 32 root 3. So I have 32 square root of 3 times pi times 4/3. So basically, this is just 32 times 4 divided by 3. All right, well, I got 42.6 something, Not a choice. Not a choice. Not a choice. So a cube inscribed in a sphere has a volume of 64 cubic inches. So we know this guy, we know our cube is going to be 4 each. So we know that this is going to be, this diagonal is going to be 4 root 3, but we just want half of it. So it's 4 root 3 over 2. That's the radius. And we know that the formula for the sphere is 4/3 pi r cubed. So all I have to do is replace this here. So I have 4/3 times 4. So this is what I think they did. Just so the first thing, there's pi's in the question, there's pi's in the answer, so we're gonna throw that out. The second thing I did, I think they did √3 times √3 with another √3 left over. So that way, because this is times 3 times, so if you times it twice, we can have a leftover one. So that's gone. So the √3 and the pi are gone. So this is what I'm left with. So I have 4/3 times 4 squared times 3 over 2 squared. Because it has to, the exponent has to go to each of them. So 4/3 times 16 times 3 divided by 4. Okay, and then I'm just going to cancel stuff. There's a 4 on top and 4 on the bottom. There's a 3 on top and a 3 on the bottom. I got left with 16. 16 is right in the middle of these two, which is kind of annoying. Yes, I could use the calculator and just try it in general. So this is a graphing calculator you can use. It's desmos.com. It helps me sometimes when I get confused. So I know this is 4 times √3 over 2. I believe that's what it is. It's just 4 is the distance. It's just times a. So they say our diagonal is square root of 3 times a. So that's 4 times square root of 3 divided by 2. So let's try it. So if I click this on the bottom, it opens up. So 4 divided by 3. All right, and now it's going to be 4/3 parentheses 4 square root of 3. This whole thing is divided by 2. Oh, I see where I messed up. Cool. So this whole thing is supposed to be cubed, but I raised this one to the 2 to move it over here, but it's really to the third. So this is to the third power, and that's to the third power. So this is 64 over 8. That's it. See how easy it is when you make a mistake to see it. So it's 4/3 times 4 cubed times 3 over 8. So it's times 64 times 3. And this thing, this whole thing is going to get divided by divide. Oh my God, it just doesn't want to be my friend. So I can do the little trick I was going to do before, but that's okay. We got the calculator here. There we go. Our answer is 32. We can cross these out. The 3's cancel. And then this is 64. 64 divided by 8 is 8. And 4 times 3 is 32. This is what I was going to do. So there's just the shortcut. You can cancel tops and bottoms. But either way, we got the right answer. It's going to be 32 pi √3. So 65 is C. I doubt you're going to get one that hard, but it's good to see it, challenge yourself, challenge your students. 65, let's see. Mandy can buy 4 containers of yogurt and 3 boxes of crackers for $9.55. She can buy 2 containers of yogurt and 2 boxes for $5. Okay, how much does the crackers cost? So this is a typical problem. You're going to see this a ton. You're going to see this number 66 problems like this constantly. So we just have to make one X and Y. So I'm going to make, or we can make one Y for yogurt. And we're going to do C for crackers. So 4 containers of yogurt plus 3 crackers equals $9.55. And then I've got 2 yogurt and 2 crackers for $5.90. There's a bunch of ways we can do this. You can use substitution, elimination, and graphing. You know what I'm going to do? I'm going to show you all 3. Isn't that nice? We're going to do elimination first. Elimination is usually the easiest way to do a problem when they're like multiples of each. See how this 4 and 2? If I multiply this entire bottom line by -2, I still have the same top line, which is 4y plus 3c equals 9.55. The bottom line, I just have to distribute the, I just have to distribute this, sorry, I just have to distribute this -2 to each part. And remember, it also goes to the last part. That's a common mistake when using elimination method. So that's -4y plus, what is that? -4c equals well, 590 times 2 is 1180. And if you don't believe me, that's okay. $11.80. So all we have to do is add up. So if I add up the whole thing, like everything, these cancel. I'm left with -1c equals, well, we could just subtract 1180 minus 955 because one's positive and one's negative. $2.25. It's a -$2.25, but we can make it positive, right? By dividing both of them by -1. And that's how we got the positive $2.25. So that's elimination. Now, graphing is also pretty easy. So we have these 2 again. I'll show you elimination though. So we have 4y plus 3c equals 955. And we've got 2y plus 2c equals 590. Now, let's get c by itself because we're solving for c crackers. So I have the minus that you solve for one, you plug it in for the other. So we minus 2y to both sides. Actually, no, you always want to at first solve for the other term, you'll see why. Because then you got to do an extra step. So we're actually going to subtract the 2c from both sides. So I'm going to be left with 2y equals -2c plus 590. We're going to divide both by 2. Remember that lotus flower technique where we divide this side and this side? So I'm left with y equals -c and 590 divided by 2. Decimals here. 2 goes into 5 twice. 2 goes into 19 9 times. And 2 goes into 10 5 times. So it's basically, we know that y equals c plus $2.95. Now, I can take all of this, -c plus 295, and drop it into the other equation. You take one, you replace it with the other. Sorry, we're replacing it here. My bad. And we take this whole equation, this negative c, and we're going to bring this in for y because that's what y equals. So our new equation is going to be longer, but guess what? It's only in terms of c. So it's 4, not times y anymore, negative c plus 2.95 plus 3c equals 955. Notice it's a much longer, but now look, there's only c's here. So we got negative 4c plus 295 times 2. 295 times 4. 1180 plus 3c equals 955. So negative 4, positive c, we're combining like terms. Negative 4c's plus 3c's negative c plus 1180 equals 955. And if we subtract 1180 from this, guess what? We're left with the exact same amount of the crackers. Negative c equals a negative $2.25. So a positive c equals a positive $2.25. That's substitution. Now, substitution works really well, especially when these aren't easily added or subtracted for elimination. This was easy to do because I had a 2 and a 4, right? That's easy to go. But if it was just this 3 and this 2, let's pretend this wasn't there. If it was just this 3 and this 2, you'd have to multiply this by 2 and this by 3, negative 3, and then add them or subtract them. So sometimes the substitution way is better. The last way is the graphing way, okay? So the graphing, we have to solve both for y. We solved the bottom one for y. Now let's get the top one. 4y plus 3c equals 955. So 4y, I'm going to minus 3c to both sides. 4y equals negative 3c plus 955. Then all we have to do is divide both sides by 4. Remember our lotus flower. So I'm just going to leave it as y equals negative 3/4 c. That means down 3 over 4 plus, and I'm just going to leave it like this, 955 divided by 4. Because we're just going to put in the graphing calculator. So here's the last one. So we have our two equations. We just have to draw them and see where they meet. This is your first equation right here. Now this means the 2.95. So y equals, so we have a negative x. See, that's the slope x. And this is your b. This is just where it crosses it. So I'm going to go plus 2.95. There's the line. But that's what this is. Negative x means look down 1 over 1. And this is where we start the 295. That's your y-intercept for the y equals mx plus b. This is where we start, which is this point, and then this is your slope. That's your slope. Now we have your other equation. Now it's y equals negative 3/4 x. Notice it is less steep. Now we go down 3 before we go over 1. Go down 3 before over 1, 3 before over 1. And I have to raise this up. Oops. I have to raise this up. 955 divided by 4. I knew it'd be a weird decimal, that's why I didn't want to do it, but where do they match? Our crackers are 225. We got 295. All right, well, there's a mistake here. When I graph these two, let's find it. Oh, because it wasn't that. The answer wasn't $2.25. Haha, no mistake. And if they wanted the yogurt, it's 70 cents. Yes. All right, so here we go. $2.25. Let's do it. All right, 67. Oh, sorry, what number was that? That was C for 66. And don't worry if you're missing some of these. This is just a pretest. We're going to learn as much of this as it makes sense. Which of the following describes how to find the volume of regular solid prism? So to get the volume of anything, like let's say it's this statistics book from the other class that I'm building right now. It's always the volume of the bottom, the base, times the height. That's for every possible shape. It's just the bottom of the base times the height. That's if it's a prism. Prism means flat on top, flat on bottom. Pyramid means flat on bottom, but then it creates a triangle. So this one is find the area of the base and multiply by the height. It's just the formula. So 67 is B. And if you really want to see that one for 67, doesn't matter what shape the bottom is, like a square, and then there's a shape on top that's a square. All you have to do is, oh, that's really ugly. So if you have a prism, it just means the flat bottom and a flat top. It doesn't matter if it is square, right? Doesn't matter if it's a triangular prism. Just means you have rectangles around the sides. That's all it means. And that's how you do it. Okay, so what is A and B? So for 68, oh, sorry. What was the answer to this one? It was B. 67 was B. I already did it. Okay, so 68. So we got to know what these symbols are. So this one means end. And math is all about vocabulary and symbols, okay? This one means or. If there's a little C by it on the top, this means not. So if I have A, and here's a Venn diagram. Here's A, here's B, and in the middle is where they match. So A is 3, -4, and 1. B is 0, 5, 9, and 2. Is there any single thing that matches? Is there anything that matches? Now, if it was A or B, it'd be all of them, right? If it was A not B, it would just be this half, right? It was A not B, but they just want what? They just want A and B. Do they match at all? No. So this is what this means. This is the 0 or empty set. It means we got no matches. So 68 is D. All right, we're moving to 69. Which would best over time? Okay, so I got to show you what each of these are. So 69, whenever they have pie charts, right? This is always for percentages, totals, things like that. Bar graphs are always used for comparisons, like men and women stuff. Line graphs always show trends over time. There's more. Oh, okay. The box and whisker, the one that I drew before, the box and whisker, this shows the spread of the data. And this one, the Venn diagram, shows relationships. So changes over time, line graph. Beautiful. So remember, comparing like men and women and stuff like that are different groups. Comparisons of groups is the bar, percentages or totals the pie. So this is your pie, bar, line, your box plot, measure Venn diagram. Now the Venn diagram usually has a big box around it because sometimes people don't fall in any of the groups. Just so you know. So, okay, so 69 was B. I think there's only like 10 more to go. Oh, and then I have to do the couple I skipped. Or we can skip the couple and you can we can look at the answers to them. All right, so 70. Which of the following activities is most appropriate for developing first graders' concept of measuring objects? I think it would probably be giving them the actual objects and rulers and like having them measure. Measuring the height of the pencil sharpener using a meter stick. I like it. Measuring the length of the chalkboard using a tape measure. Measuring the width of the desk using dominoes placed end to end. This is probably not, because you're not using a tool here, so it shouldn't be C. Measuring the circumference of a trash can using cloth tape. I don't like this either. So which activities is most appropriate for developing first graders' concept of measuring objects? I like A lot, but it says objects measuring the circumference of a trash can using a cloth tape. Measuring the length of a chalkboard using a tape measure. Okay, I feel like the tape measure is probably harder because you're not going to have the 0, so I'm going with A. But we'll see. This one I could have gotten wrong. I feel like this is probably the best way for objects because you do multiple objects with the meter stick. I feel like they're good. They might get confused. I think this is be the easiest to use. Dominoes, they don't have a regular 0 with. I don't know. I think I like A the best if it was my class. All right, geometry, similar shapes. So this one is always proportions and ratios, and we'll do a lot of that in this class. So here we go. Here's 71. So I've got these two rectangles. They say that they're rectangular prisms. And basically, all we have to do is create a proportion. So I have 18, 6, and 8. I have 12, 4, and who knows what. So we can pick whatever one we want, right? We can pick whatever one we want. I'm going to use these two because they already look like a fraction. You can use any one you want. So this means it's 8 over 6 equals x over 4. If you don't have it written out, it's going to be harder to do. There's a bunch of ways to do this, but this is the way my students always remember it. I'm going to draw a thorax, some antennae, and butterfly rhymes with cross multiply. So 6 times x is 6x. 4 times 8 is 32. Divide by 6, divide by 6. All right. The 32 is big. It goes in the house. The 6 is on the bottom. It's outside the house. 6 can't go into 3. 6 goes into 32 5 times. With a what left over? With 2 left over. And 6 goes into 20. Sorry, I'm just running out of space. 6 goes into 20 3 times. With 2 left over. So I got 5.33. 3333. That's 5 1/3. So it's B. So yeah, that's how I did it. I got 5.333. That's a third. I like it. So for 71, I got B. Okay, let's go to 72. We're almost done. All right, so Kim's current monthly rent is 800 bucks. She's moving to another apartment complex where the monthly rent is 1,100 bucks. So her monthly rent increase. Okay, we have to figure out the percent increase. So here's 72. I'll draw it up here. So here's 72. So it used to be 800 bucks equals, now it's 1,100 bucks, right? We have to figure out what happened, right? What percent did it go up? What's our percent change? We can think about it. It's 1,100 times some value gives us 800. That's the best way to do it. So we can do 1,100x. This is probably how I would show my students to do it. It's 1,100 times some value to give us this 800. Or is it 800 times some value to give you the 1,100? this is like kind of what we have to think about. What's the percent increase? So either way, should get the right answer. So let's divide them both. You know what the first thing I'm going to do? Do you see how I have all these extra zeros? I don't like them. They worry me. So I'm going to make it so it's 8 over 11. And we'll see what happens, right? So 8 divided by 11, which means I have the 11 over here. Sorry. I've got the 8 over here. I got the 11 here. There's my decimal. So it's 7. And I got 80 divided by 7 is 30. So I got 0.72. Okay. And 11 goes into, okay, that's 22. And then 11 goes into 80 7 times. So I got 0.727. I got a 72 point, or 73%, right? I got a 73% kind of increase going on. So what is 100 minus that 73%? I got 27%. Now let's see if this really makes sense. Let's see. So that's how I would do it, because that's how much it goes minus 100, whatever's left over. But let's use a calculator to see what's really going on here. So if I have 800, what is 800 times 0.27? Because remember, percent means we have to divide it by 100. So the first thing I'm going to do, sorry, is 27 divided by 100, and that's how I got the 0.27. Now I have to multiply this by the 800 bucks. I got, oops, sorry. So I have 800 times 0.27. I got 216. So let's see what happens. What is 216 plus 800? Let's see if that gives us close to the $1,100 we need. And it's only $1,016. So I didn't get the right answer. Okay, it's okay. That's fine. Do we make mistakes sometimes? Of course we do. So let's try 7 again. We're all human, we make mistakes. So it's 800 times some value. Then we have to add that value, whatever that value is, to get $1,100. This is a way to use your answer choices. We could do 800 times 0.255, and whatever we get, we could add to that and see if we get the $1,100. 800 times 0.255 is 204 plus 800. So we have to add this to our original value plus 800 to get the value. See, it's still too small. So this is the way this is just using the choices. So 800, and then I'll show you the formula because I messed up the formula, times 0.35 plus 800 is 1080. Not quite, so it's 37.5. 800 times 0.375 plus, oops, I hit divided by, 800 times 0.375 plus 800. Okay, so what's the right way to do it? We know it's D. Let's see the right way to do it. So we know it's 800 times X, right? Plus 800 equals 1,100. This is how we can do it. Because we need the percent of what we started with to get the answer. So it's going to be whatever percent or change, right? Whatever percent increase times the original value plus that, because we got to add it on. So the first step I'm going to do is I'm going to subtract 800 from both. In order to do a problem like this, an algebraic problem like this, you always have to start as far away from that x as possible. I use solving, this little acronym I tell my students. Solving sometimes makes us sad. So it's sad math. It's just PEMDAS backwards. It works 90% of the time. So we're going to subtract before we divide. So I'm left with 800x equals 300. Now I just have to divide both by 800. And now what I always do is I just cancel the zeros. So x equals 3 divided by 8. The 3 is special, it's inside the house. The 8 is outside the house. 8 can't go into 3. Sorry, it's storming out there. 8 goes into 30 3 times. That's 24. Since we have a decimal, we can bring down as many zeros as we like. 8 goes into 67 times, that's 56. And I'm left with 4. And 8 goes into 45 times. So I have 0.375. If we want to add the percentage, we want to add in 2 zeros. If I want to go from a decimal to a percent, I have to multiply by 100, which basically just means I'm moving the decimal 1 place, 2 place. That's why your answer is 37.5%. So 72 is, guess what? It's D. All right. A teacher asked students to find the error in this algebra problem. What is the error? All right, so we might as well write it all out and see what happens. So here we go, 73. 3x plus 4x equals 2 squared plus 1 in parentheses plus 2 times 2. All right, so we're just going to work it out and see where the mistake is. 3x plus 4x, that's 7 x's. 2 squared is 4, plus 1 is 5, plus 2 times 2, which is 4. So I have 7x, which equals 9. Divide by 7, divide by 7. And I have x equals 9/7. What did they do wrong? Oh, they multiplied instead of added on the third step. Oh, no, they added these two instead of multiply. So they didn't do it. So the student incorrectly added before multiplying. The student incorrectly applied the exponent. Nope. Student incorrectly. Nope. Yeah, so they added the 5 and the 2, but you have to multiply first. So 73 is A. These mistakes happen all the time. You just got to kind of start getting used to them. All right, let's keep on going. A few left. All right, so here's our line. I know I showed you this before, but these are really nice. So y equals negative 4x minus 6. So this is in the y equals mx plus b. Remember, this is our friend Descartes. He's trying to catch those flies. So negative 6, this is our b, our y-intercept. So that's 1, 2, 3, 4, 5, 6. Other things you can teach your students is that we have the Roman numerals that go counterclockwise. And we do this because there's so many numbers on there that we get confused. So that's why they use the Roman numerals here. Here's our origin. There's everything. So we're starting at negative 6. And now our slope is negative 4. It goes down. So I want to go down for a room, but I ran out of room. So instead of going negative 4 over 1, because I want to make this a fraction for my rise over run, I'm going to do positive 4, negative 1. So I'm going to go up 4, 1, 2, 3, 4, over. Up 1, 2, 3, 4, over. So here's my line. Ta-da. Well, let's see what choice that is. I like this one. Let's see what the other ones look like. This one looks too slopey. Up 1, 2, 3, 4, 1, 2. All right, so that's over 2. So this one's not right. I like this one the best. Up 1, 2, 3, 4 over 1. Yeah, that looks nice. And this one's, yeah, these, I don't know how these two are different. All right, well, whatever it is, I'm going B. They made them all look super similar. That's okay. 74, I'm going with B. Now let's do 75. All right. Andrea must administer 1/12 of the medicine bottle to a patient. The bottle contains 3 and 4/10 of medicine. How much medicine should be delivered? Okay, so this is a measurement problem. It's in the geometry section. A measurement and conversions are really tough for students, but I think it's really useful. Useful for cooking, useful all the time. So we have to do 1/12 of a medicine bottle. The whole thing contains 3 and 4/10. So 1/12 of this. So basically I have to take 3 and 4/12 and divide this by 1/12. Oh, sorry, just divide it by 12. If I want 1/12 of the bottle, I'm basically multiplying this by 1 over 12 or dividing by 12. So let's work it out. The first thing I'm going to do is with this mixed number, this 3 and 4/10. I'm going to multiply the bottom and add the top. So this is 30 plus 4. So I have 34/10. And now I'm going to multiply this thing by 1/12. Why? Because it's the same thing as dividing by 12. So I'm left with 34 divided by what? 120. And then they simplified. How they simplify? They divided by 2. 34 divided by 2 is 17, and 120 divided by 2 is 60. That's your final answer. It's A. So 75, I got A. We're moving on. Okay. Which of the following options represents equivalency? So we have to see which are equal. So we have these choices. So here's 76. I have 3 plus x plus 3x plus 3 plus x equals 5x plus 6. Let's see what we have. 3 plus 3 is 6. 1 plus 3, because you can pretend there's an invisible 1 here. So that's 1, 1, 1 plus 3 plus 1 is 5. It's A. This one, 7 minus 2 is 5x. This one, 2y plus 2y plus 2y is just 6y. You don't add the 3's, this is the exponent, and this is 2.5x plus, this is a distributive property. So this is 2.5x plus 5. So it's 76 has to be A. Okay, next. All right, see, as I said, money, percentages, budgets all use the pie chart. So Kendra uses a pie chart to represent the allocation of her annual income. She's got 40 grand. So we're just going to get everything. They're asking you for just a little piece of this, but guess what? We're going to do it all. Why? Because why not? It's almost the end, so. But here's your 77. We have $40,000. So each of these, we just have to multiply. The first one's 40,000 times 0.15. So we know travel is 6 grand. A lot of this stuff is just multiplication, but that's okay. So the next one's $40,000 times 0.10. So savings should be 4,000. All right, the next one is leisure. So 40,000 times 0.17 is leisure, which was 6,800. Groceries is 40,000 times 0.20. So groceries is just double this, so it's 8,000. And finally, 40,000 times 0.38 is the rent. Is 15, the rent 15,200. Yeah. And look what happens when we add them all up. We get the total, which should be 40,000. So 15,200 plus 8,000 plus 680 plus 4,000 plus 6,000. Did I skip one? All right, well, let's see. 15 plus, sorry, 15 plus 10 plus 17 plus 20 plus, what's going on? Fifteen plus 10 plus 17. This is why I like doing everything by hand. Plus 20 plus 38. I feel like it's not the whole 100%. It is 100. Okay, so let's see where the mistake is. Did I forget the zero here? Who knows? 15,200 plus 8,000 plus 6,800 plus 4,000 plus 6,000. Okay, well, wherever the mistake was, I found it. So the amount of money she spends on travel and savings is 10 grand. Nope. The amount of money she spends on rent and utilities is approximately 15. Yes. The approximate she spends on groceries and savings, groceries, 8,000 is, no, it's not more than, it's less than. The amount of money she spends on leisure, nope. Yeah, so the rest of them are wrong. All right, so we're up to 78. This one was which one? B. 77 was B. All right, let's go to 78. In a pack of 20 jelly beans, there are 2 licorice, 4 cinnamon. What is the probability of choosing a licorice followed by? So this is where it gets tricky. So this is a probability question. And the reason why this is hard is because we pick one and then we pick another one. So if I pick one and then pick another, there's less in this, we'll call this the pack. I have 2 licorice. And I have, how many cinnamon? 4 cinnamon. But there's 20 others, right? So it's always what you want over the total. So our total was 20. And the first one we want is the probability of choosing a licorice. That's 2. But then we're doing something else. I took the licorice one out of the bag and I ate it. Now there's only 1 licorice left. which makes my 20 now drop down to 19. And how many cinnamon? I didn't take the cinnamon, so that's 4. So it's really top times top is 2 times 4, which is 8. And I have 20 times 19. 20 times 19 is going to be a big number. So I don't want to use the calculator anymore because it was frustrating me. 0, 18, blank, 0, 2, 380. Now we have to make this smaller. I believe we'll be able to divide this by 4. Let's find out. 8 divided by 4 is 2. What is 380 divided by 4? Let's see if this works. 4 can't go into 3. 4 can go into 38. How many times? Is it 9 times? Yeah, because 4 times 9 is 36. And 4 goes into 20 how many times? 5. I got 2 out of 95. And ta-da! That is our final answer. So we got 2 out of 95. So that 78 is C. And let's look at the last two. Amy says 450 bucks over 3 months. How much did she save after 3 years? Well, Amy's a great saver. So here's 79. And we have so you have a choice. I like breaking everything into months because it has months, so why not? So if we do 450 every 3 months, right? This is for every 3 months. So we do it a million ways, but 450 for 3, right? Now we want 3 years. Well, there's 12 months in a year, so 12 times 3 is 36. So we could do the butterfly again, or we could do like 3 times what is 36? It's 12. So all I have to do is 450 times 12 to get the right answer. And guess what? Zero, carry the 1. 2 times 4 is 8, plus 1 is 9. Blank, because we're in the tens place. 0, 5, 4. So our final answer has to, I don't know, I like the butterfly better, but I keep trying to show you different ways to do the problems. You pick whatever way is the best. 5,400, it is C. And I know I'm taking a long time with this, but I'm really trying to go slow and explain everything. All right, so 79 is C, and I think this is our last one is 80. Which of the following? Oh, okay. So associative, commutative, identity. What do these words mean for 80? We'll definitely be going over them. So when they say, this is why vocabulary is important. If they say commutative, there's also identity. There's 2 types of identity, adding and multiplying. Then there's distributive. And there's associative. I'll save this one for last because this is the one that the problem is. So commutative is literally A plus B equals B plus A. And it works for multiplication too. Does it work for division? No, because A divided by B is not B divided by A. So this works for addition and multiplication. Now the addition identity is basically means A plus 0 is A. Adding 0 to anything gives you what you started with. And the multiplicative identity is A times 1 is equal to A. You multiply by 1, you get it. Distributing A, B plus C is equal to AB plus AC. And here's the associative. It's basically just associating, grouping together. So like commutative, you can think like going back and forth. Identity is like looking into a mirror. Associative is like you're grouping things like an association. So A plus B plus C. And this works with this doesn't work with multiplication. Depends how it's written. So this just means if I have A plus B first, it's the same thing if I group B plus C. So this is distributive property 3 times 6 times 2, 4 times 2. No, that's not right. 2 times 3 times 4, 2 times 3 times 4. There it is. And this one's the commutative 6 times 4, 4 times 6. So 80 is C. And that's the end. All right. So I might as well go back to whatever 3 I missed out of these. I don't know. Was it 40 problems? I think I didn't do B. So 54 and 45. All right, let's start with the 54. The set, which is true. Oh, I went with 3. Inverse means the opposite. Is it commutative? Yes. Is the identity element of the group D? Well, we know it can't be 1. So we have no, I feel like it'd have to be D's across the board for it to be the identity. D is times D is itself. Is C times C itself? Is B times B itself? Oh, no, it is. So I'm going with 1 and 3 because it's being multiplied by itself. And 2, the inverse of C. C, I don't know. Sorry. I think I'm just gonna go with that. We'll see if I mess it up. And let's look at 45. Let's see what I did wrong with 45. Okay. So let's see how to do it. So Zeke drove from his house to a furniture store in Atlanta and then back along the same route. It took 3 hours to drive to the store. So I go 3 hours one way, and then I go 3 hours back. Oh, it's just 3 hours one way. By driving an average of 20 miles per hour faster on the return trip, he was able to save an hour. Oh, I missed this line. So it says he was able to save an hour of driving time. So this is 2 hours back. So this one is 3 hours, and this is only 2 hours. And this is X, and this is X plus 20. Ta-da. I missed that it took him, he was able to save an hour, so I missed part of it. So I have X over 3 equals X plus 20 over 2. You all make mistakes. Like, I'm pretty sure I got that one wrong. So I'm just going to make my cute little butterfly. So this is 3 times X plus 20. And this is 2 times X. All right, so we have 3X plus 60 equals 2X. All right, then I have to minus 3X to both sides. Oh, it's faster. So it's not plus 2X. Wait, no, it is faster. Okay, so I have negative X equals 60. That doesn't make much sense. So if it was faster in miles per hour, yeah, that makes sense. What was Zeke's average driving speed? So I'm telling you that he went 60 for 3 hours. Then he went 80 for 2 hours. So let's see what that makes it. So I have 60, 60, 60, 80, 80. And let's put them all together. For the average round trip. Looks like I still made a mistake here. That's okay. So it's 60 times 3. And then it's 180 plus 160 divided by 5 because we have 5 hours. I got 68 miles per hour. That is not a choice. That is not a choice. So let's see what it is. I guess I can use the choices now. So if I did let's do one in the middle. Let's start with 50 hours. So the average speed driving on his round trip is 50 equals I can do 3x miles per hour. So the hours have to be on the bottom. So 50 equals divided by 3, and then it's 3 hours. So let's do 50 is 1/3 x, and then 20 miles faster. So plus 1/2 x plus 20. I don't know why I'm having a moment. I think it's because I've been doing them for so long. So I'm just gonna guess. I'm gonna guess 48 just for fun. And let's see how many that were right. And we might as well see the one that I missed. So I'll just go to finish. Yeah, that's fine. Let's see how we did on. So I missed 5. Do they give the answers? Sweet, they do. All right, so let's see the ones we missed. So let's start with let's first see how to do the one that I missed. You know what? We're all human. We all make mistakes. So I missed 5 of them out of the 40. I like it. So let's see the pretest. And the first one that I struggled with was 45. I managed to guess that one right. So let's look at 45. Miles per hour is time over hours. Okay. Is the distance over the time. So it's 1/3 and 1/2. Okay, that's fine. So that's the first distance over 3 and distance over 2. Oh, that's so interesting. So it's the speed home minus the speed there is 20. That's where the difference comes from. Okay, so D2 minus D3 is 20. Okay. So let's think about this. And why do we have 6? 3 hours to drive to the thing. Okay. No, for 9 plus 53. Where D is the distance between the 2 houses. He's drew 20 miles faster on his way home. Ah, okay. So they want us to first just get rid of the denominators. So they said 2 and 3, the first time they match is a 6. But if you multiply one side by 6, you got to multiply the other side by 6. So that's going to be 6D divided by 2, which is 3D, minus 6D divided by 3, which is going to be 2D, equals what? 120, which makes D equal 120. Okay, that makes sense. And since the distance between the house and the store in Atlanta is 120 miles, he drove a total of 240. Oh, okay. So this is just one distance, but we have to double it for going back and forth. That's 120 there, 120 home. So that's 240 divided by the 5 hours. No wonder why it was so strange. So it's 48 miles per hour. I just took a good guess based on the values. That's okay. All right, let's see the ones I got wrong. Might as well, right? All right, so the first one I got wrong was 54. Is that this one I starred? Yeah. Okay, so how do you do 54? Oh, two worked also. Okay, crazy. The identity element is D, since D and A equals A and D, which equals A. I got that. D and B and D equals B, D and C is C. Okay, cool. It doesn't matter which way you go, you get their values. Okay, so I thought that was the right, but it was commutative. Okay, so the inverse element is C, since the inverse element C, since C and C equals D, the identity element. Oh, because if it's multiplied by itself, we get the identity. That's why it was two also. A and B equals B and A and C equals C and A. That's the commutative. So the only one I got right was commutative. But the reason why it's this, rather than check that the elements display symmetry, rather than check that the operation is commutative for each pair of elements, note that the elements table, symmetry, and diagonal. This thing. Oh, that's pretty. Okay, cool. So I missed that one. Let's see what else I missed. Let's look at 55. 55. And how many? Oh, it's the seating one. Yeah. So I went with 60. So they drew them all out. I did not want to draw them all out, but they drew them all out and there were 12 ways. 1, 2, 3, 4, 5, 6. One way to approach this problem is first consider the number of arrangements of the 5 members of the family. If Tosh and Mac must sit together, treat them as a unit in a fixed location. So that's 1, 2, 3, 4, 5, 6. There are 6 ways to arrange the 4 units around a circle as shown. Any other arrangement would be a rotation in which the elements are the same and therefore would not be a unique arrangement. Of course, Mac and Tasha are not actually a single unit. They were sitting beside each other. If they were to trade seats, there are 12 arrangements of the two. Therefore, they are separated. Therefore, to find the number of arrangements with attachment are not sitting together, subtract the 12 from the possible arrangements of 5 units around the circle. There are n minus 1 ways to arrange the units. So, see, I was including the first one. So I was doing 5 factorial, but it's really 5 minus 1 factorial. And what does that mean? So when they say 5 minus 1 factorial, oops. Because the first person, I guess, doesn't count because we're sitting in an order. So that first person you can remove from it is 4 factorial. And this factorial just means you're multiplying 4 times 3 times 2 times 1, which is 12 times 2, which is 24. And they literally had to write them out. But we can think about this as 3 factorial for the other people, because if there's 3 people that can be in any order, it's going to be 3 times 2 times 1. This is the 6 other ways because there's 3 people because they have to be together. And then why is it double? Because we can go TM or MT. That's really annoying. That was super hard. Okay, let's see what other ones I missed. I missed 54. I missed 55. All right, let's look at 56. So I did a reflection across the x-axis, which lands here, and then I did 90 degrees about the origin. So a reflection across the x-axis. Oh, would it be the other way? A reflection would result in the triangle of 2, -3, 4, -7, and 6, -3. Oh, because these are going counterclockwise, we always do this opposite of a clock. So it's one, I think I wrote them wrong. It's been a long time. So it's 1, 2, 3, 4. Is that the quadrants? One, two, three, four. Yeah, okay. So maybe I wrote them wrong before. So if I'm going, if I'm, I was going clockwise instead of counterclockwise. That was a simple mistake. So if I have this and I flip it over and I go 90 degrees, I'm back here. I'm turned. My last move will be here if I go 90 degrees. That's why I have to go 270 to come all the way over here. I had them mixed up. That's okay. That's not a bad mistake. All right, let's go all the way to 64. What is the length of the hypotenuse of the triangle shown before? I put 8√2. I have 8√2. Did I just click the wrong one? √2. I clicked the wrong one. Make sure you click the right answer. 8√2. All right, so let's see what else. That was 64 and finally 70. And 70 was, oh, they didn't like my meter stick? Dominoes. All right, let's see the reason. Oh, that's a long reason. Students in first grade are generally in Piaget's pre-operational stage, but they're making their transition to concrete operational stage. Pre-operational stage children are beginning to think symbolically about concrete objects, but are unlikely to think abstractly. An activity to develop understanding of measurement, it is best to use concrete manipulative objects to avoid measuring involving conservation. At this concept developed in later stages. Oh. But are unlikely to give you them the stimulation of a nib. Okay, so they want to use small pieces to create it without the actual markers. And I should have known it was wrong because the tape measure and the meter stick are very similar. Should always look for the one that's different. And the next one has geometry concepts. Okay. Oops. So like if you go back to it, I think that was the last one I missed. I think that was the last one I missed. So I missed 5. Even though there was one was a stupid mistake. So I missed 5 out of. So I did 41 to 80. So we can do. And let's just figure out how we did it. So once you get to your final answer of how many you got right. So 80 minus 41 should be 40 problems. Or 39 problems. Oh yeah, that'd be 40 to 80. So I did 39 problems. I got 5 wrong. So 34 out of 39. So 34 is inside the house, 39 is outside of it. Let's see exactly what we got. I got an 87. Not bad. And once you have your answer, I just want you to represent it visually. So if I had 87%, I'd probably draw it like this. So once you have your final answer, in my case, it was 87%. I would draw it this way. This is how my brain sees 87%. Everybody visualizes things differently, you know? But in my brain, when I see 87%, I see this. I see that much of the box filled. So 0.87, 87%, or was that 35 out of 39? 34 out of 39. So whatever you get for this, I just want you to represent your answer in three ways, just to get a better sense of it. These were harder than the ones that you're going to see in this class. Why do I want to give you ones a little bit harder? Just because I think it's good to place to start. I think it's a really good place to start, to just see everything. That's everything that you could possibly give from grades 1 through 6. So that you could be expected to teach any of those ideas, whether it's the geometry stuff, the algebra stuff, the data stuff. So hopefully it was helpful to see them. Did I mess them up? Sure. We're all going to mess them up. But just don't freak out and try your best. And obviously reach out if you have questions.